And welcome back. All right, so I got so completely excited on my last one at the end of 2.4 part 1, okay, that I made you go out and grab an extra sheet of paper just to go ahead and write this whole thing down. You're not realizing that this was coming up next, so I'm sorry about that. So this is just a rehash of the exact same thing that we did. So I want you to do is quick pause the video. Yes, pause the video, pause the video, pause the video, and copy this down. Pause. Okay. I'm glad you're back. All right, so now that you've copied everything down, I want to reiterate how amazing this is. The amazing part of this is that if I wanted to choose any point A for on x squared, okay, and go a little bit to the a little bit over h units, that this represents the slope of that secant line. How amazing is that, right? Now here's what's even more amazing, and this is what I kind of alluded to earlier. It's like, what if h keeps getting smaller and smaller, okay? If h gets smaller, and there's my new h, boom, there's that secant line. And I can find the slope of that. What happens if h gets even smaller? Boom, there's that secant line. Now I can find the slope of that. Okay, what happens if it gets super, super small? All of a sudden I can find a tangent line. Huh. So I found a whole bunch of secants and then a tangent line. And that's essentially what this next slide is saying, is that I can find the slope of a curve at a single point. This point right here is if I take the exact same difference quotient and I take the limit as h goes to 0. Dude, how amazing is that, right? Now all of a sudden I can find any slope at any point on any function just by doing the difference quotient. Wow. How cool. All right, so let's actually do that, huh? Okay, well, not quite yet. I'm getting ahead of myself. All right, so because we're math people and we like to call things by different things, like Billy, Bob, okay, a whole bunch of, Williams and Roberts, they're all called pretty much the same thing, right? But here we are, so all of these mean the same thing, okay? The most common type that you will see is the slope of the tangent to y at x equals a point. And number 3 here, the instantaneous rate of change with respect to x, okay? Those are the two most common ways that you're going to see this, but it's also just the slope at that point, which is what number 1 is saying, and this new little thing here, which tells us the slope at any point. Again, amazing. Slope at any point A. Holy cow. Okay. All right. So let us keep going, and this is where we're going to have some fun. All right. All right. So this one here, I keep getting ahead of myself. Guess I'm so excited. This one here, this is just this slide real fast. One of the things, again, that's just mind-blowing about this whole process is that you're so used to having 2 points. 2 points. To find the slope of a line, right? 2 points. Always, you need to have 2 points. You need to have 2 points. Now what I'm saying with that whole limit thing, all we need, okay, is we need a point and a function, and I can now find out what the slope is at that point. How amazing. Oh, that is amazing. All right, just let this soak in. If you need to, pause the video, let this soak in. I now have something to where all I need is a point and a function, and I can find the slope at that point. Okay, next. Now this is where we get really excited. All right, so here we go. So first thing you want me to do is find the slope of the curve at x equals a for part A. Here's my function, 1 over x. So I want to find that slope. So that means I need to know this. I need to know the limit as x approaches, not x, h. H approaches 0 of f of a plus h minus f of a all over h. So now I'm going to go ahead and plug in. X is a, so now I have here the limit as h goes to 0 of f of a plus h. But I'm just going to write that out, okay? I'm going to write that and say that that's going to be 1 over a plus h minus 1 over a all over h. Again, if you didn't notice, there's my function right there, okay? Now this is, you're going to realize, oh my gosh, I should have been listening at the summer packet, and I would say yes, you should have been listening. So I'm going to just, by now you should have this down. I need to get a common denominator to subtract this, so I'm going to multiply that side by a plus h and this side by a over a. And what I end up with here is now the limit as h approaches 0 of a minus the quantity a plus h all over a squared plus a ha all over h. I take a moment here. Again, this is just the limit as h goes to 0. A minus a is going to be nothing but the negative h. It's going to be negative h all over a squared plus a ha times 1 over h. Now you go, oh yeah, I can cancel now. So I'm going to go cancel, but notice I still have a negative 1. So now I have the limit as h goes to 0, all right, of negative 1 over a squared plus ha. And now as h goes to 0, I simply plug in 0 for h, and I get this to be a negative 1 over a squared. And this again is where you're going to go, oh my God, what did I just find? I found the slope at any point. All I have to know is the x value, and I can find the slope. Oh my God, how amazing is that? How amazing is that? All right, so I did that. That was part A. Boom, got it done. All right, so let's move on to part B. Part B says write the equation of a line at tangent x equals a. So again, okay, if you weren't stressed enough for this before, when you were asked to find an equation of a line, I need you to find two things. Okay, first thing you need to find for part B, you need to find a point. Second thing you need is a slope, because in this world of calculus, point slope form of a line is what we're going to use. So if I want to find a point, I'm going to go ahead and find x equals a. So that means my point is a, comma, and then I plug in 1 over a. And my slope, well wait, we just found that out, right? My slope is this right over here. So my slope is a negative 1 over a squared. So now I just plug it in. Y minus 1 over a is equal to a negative 1 over a squared times x minus a. And how did I do that so fast? Because I've written this a lot. Okay, so you need to know slope form, point slope form of a line. Okay, you gotta remember that that's y minus y1 is equal to m times x minus x1. That's, you gotta have that memorized. Okay, gotta know it. Anyway, so that's part B. Part C says take it a step further. Where does the slope equal negative 1/4? So for part C, where does my slope equal negative 1/4? Well, do I have a formula here that tells me about slope? By gosh, I do. I just figured that out right here. So they're asking me, where does my slope of negative 1 over a squared equal negative 1/4? And hopefully seeing this side by side, you can see that a is just simply at 2. Okay, but where else could it be? Couldn't it also be, ooh, this would be fancy. Okay, it could also work at negative 2. Right? Don't let me just stop there. A is plus or minus 2. Okay, fancy. Amazing, right? You just, wow, you found 2 points where the slope is negative 1/4. And you know this because of math. Before, you just have to guess. You look at it. Yeah, it looks like it's a little bit less than 1. No, now you know. How? You guys have no idea how amazing this is. All right, next, D. All right, write the equation, the normal. Okay, normal, just for your, right here, normal. That means perpendicular. That means opposite reciprocal. Okay, again, so I need point and a slope because it's asking for an equation of a line. Point for this one is going to be, let's see here, it's going to be 3, comma, 1/3. And then my slope, well, this is where we got to do a little bit more because they say my slope at that point is 1 over 3 squared, negative 1 over 3 squared, which is negative 1/9. That's my slope at the point. But I don't want the slope at the point. I want the normal, which is perpendicular. So perpendicular means opposite reciprocal. So what was 1 over 9 becomes now 9 over 1. And what was negative now becomes positive. So it's a positive 9. Next, I now use my formula up there of y minus y1 is equal to slope times x minus x1. And there's my answer. I don't try and simplify it. It's that. That's it. No more. Okay? Whew, that was a lot. I highly recommend you pause the video here, look over what I just did, make sure you understand it. Okay? Good. Now that we're back, next slide. In here. Okay, so here I'm going to do 2, and what I want you to do is go ahead and see if you can figure out the rest. So what they're saying here is I'm going to this gives you the position at time t. List the following quantities in ascending order. Again, ascending means least to greatest. So I sit down here and do average velocity between t1 and t3. So average velocity secant. So here's t1, there's t3, average velocity is my secant. So there's my secant line. And that's the value of A. Now what I want to do is I want to go through and I want to find out, so I'm going to let you do the average velocity between 5 and 6. But instantaneous velocity, that means my tangent slope. Remember, instantaneous, not one of those things. So here's 1, here's this, okay. There's that, okay. Notice, it's not by much, so I'm going to go back here a little bit. Notice, okay, this instantaneous one is a little bit steeper, right? Because this is an average between these two. So it's a little bit more steeper, okay, than my secant. This, okay. I'm going to let you think about that. I'm going to let you draw on the rest of these and see if we get the same answer when we come back. All right, here we go. And we're back. Hopefully you're noticing that, hey, that these here are, see, FPE, DAC. Notice that the average velocities are stuck between the two instantaneous velocities. Again, why? They're average. They're averaging them, right? Okay, just a thought. See if you can let that, notice again, all the negative ones come first and then all the positive slopes come later. All right? All right, I'll let you, like I said, marinate on that for a little bit. Okay, so on this one, what they want us to do is in time of t equals seconds and particle distance, all right, as of s meters from the starting point. For each function s of t, find the average velocity between t1 and t1 plus h for each of those h values. Okay, so they want to use a calculator. So here's what I'm going to do. I'm going to help you out here and organize this data. What you want is an h, okay, and they're asking for average velocity. So that's my difference quotient. That's f of t, or in this case, s of t plus h, okay, minus s of t all over h, okay. And so for this first one, they want us to go ahead and find out, this is 0.1, 0.01, 0.001. So for this first one, they want us to find out sine of 2 times 1 plus 0.1 minus sine of 2 times 1 all over 0.1. Alright, so what I want you to do is you're going to go ahead and plug that in your calculator, plug the rest in your calculator and find out values for each of these and see what we get. And I'm going to pause the video so we can go quick and fast. And you can find out what the answers are, see if we match. Alright, so take a look here. Notice these values are getting down to, it starts here at negative 1.008, negative 0.850, negative 0.834. So they're saying using these answers, we want to see if we can estimate the instantaneous velocity. Looks like it's getting close to 0.8 each time. It's taking bigger chunks. I would probably feel safe with saying a negative 0.8. So we got to, again, think to yourself, oh, so what's happening here? This means that the slope is negative 0.8, almost -1 at 1. Now remember, this is radians, okay? So hopefully you're doing everything in radians and not in degrees on your calculator. Check your calculator, because in physics you do things in degrees, and here you're going to do things in radians, okay? All right, so that takes care of that. These next slides were extra ones, and I don't know why I stuck them in here, so here we are at the end of your homework. All right, enjoy. God bless. Don't forget to summarize. Think about any questions you might have, and there'll be places you can answer those for me. All right. Whew.